Hello students, welcome to EduCell. This video is all about the problem solving session video where we are on the basis of a question we are going to solve it using certain rules. Okay. So those who are new to this video, I request you kindly visit the previous detailed videos or you can say detailed lecture videos I have already uploaded. Please go through that one if you are new to this. And here only this sessions or this categorical video will all about to solve the problem rather than going in detail about the problem. Okay. So question is solve the recurrence relation using iteration method. As we have already discussed, from recursion, the recurrence relation is being defined. The recurrence relation will be solved using four methods. One is iteration method, another is substitution method, and there is recursion tree method, and the fourth one, which is the last, is the master theorem. Master theorem, why we said as master theorem? The reason behind it is like we have certain formula. From this formula we are checking whether the results which we expected, whether the results which as per the rule it is following the method or not. If it is following the method, then as per the cases with the sub cases we found direct complexity. That's what we are saying it's a master theorem. So your iteration method we have to solve. So first of all, whenever the iteration method you are writing, first of all you have to write this part is the base condition where n is 1, like t of 1 equal to 1. This is the base condition. Okay. Now this condition when n is greater than 1, the t of n value is t n by 3 plus root over n root cube n. Okay. So first you have to write, and here t n by 3 is unknown for us. So find the value of t n by 3. This is the procedure of iteration method. So t n by 3 is in place of n you write n by 3. So here n by 3, here 3. Okay, you simplify it better. 3 and 3 is n square, or 3 square you can write. Here you can write n by 3, the power 1 by 3. Okay, I'm just simplifying it. Now uh, it's 9, just write it, because 3 into 3 will be 9. Now t n by 9 is unknown for us when we are finding t n by 3. So find t n by 9, then you place the n by 9 here in place of n. Okay, so n by 9 divided by 3 plus n by 9 cube. So if you want to simplify that one, it's n by 27. Why? Because n cross 3 is 27. Next n by 3, sorry, it's 9. N by 9, the power 1 by 3, because it's cube root. Okay. So next you substitute it. Actually in iteration we are not exactly going to substitute the value directly. In iteration we have to find out up to k times. After k times we are going to substitute one value. But to make it simpler, what I am doing, I'm just using the value which we found, like the value of n by 3. I'm just putting it here, which I got as t n by 9. Simply I'm just writing t n by 3 is t n equal to t n by 3 plus root over of n. Clear? I'm just writing it. Next, t n by 3, the value of n by 3 is t n by 9 plus n by 3 over 1 by 3, and the rest which we have written is n by 3 to the power 0. I can write over that, I can write 1 by 3. Why? Because n by 1 is n, 1 is 3 to the power 0. Clear? Next, the value of t n by 9 is, which we got as t n by 27 plus n by 9 to the power 1 by 3. You can check that one. 27, I'm just substituting the value. Clear? Now 1 by 3 plus t n 3, 1 by 3 plus n by 3 to the power 0, 1 by 3. Okay, like this I'm just doing it. Okay, next thing is, so run for k times. Running for k times, you can write running for k times Once it is running for k times, what exactly we are getting? So here, before that, it would be better. I'm just remembering that one because it's not a direct procedure we should follow. We are trying to go for a pattern that we discussed, 3 to the power 3. Here n by 3 to the power 2, 1 by 3 plus n by 3 to the power 1. I'm just finding a pattern only. N 3 to the power 0, 1 by 3. Further, if you can go ahead, okay, that could be like n by 9 to the power 1 by 3. It could be n by 27 to the power 1 by 3. Clear? So it will be like this. So here for running for k times, once I am doing that, so the Tn will be Tn by 3 to the power k. Here, how many times we are running, we have to just focus on it. Okay, like for third time if you are running, it's to the power 3. Like k times I'm running, it's k 3 to the power k. Now n by 3 to the power 2 means here 3 is there, so 2 is minus 1. Okay, k minus 1. I'm just writing that one, and again I'm just writing like 1 by 3. Next n 3 to the power k minus 2, because यहाँ पे देख सकते हो, यहाँ पे here it is written like 1, which is 3. 3 minus 2 is 1. Like this, the growth we have seen in this order. Next, dot dot n by 3 to power 1, 1 by 3. 1 by 3 is constant over any value, any power which we have written. Clear? It is done now. Next is, we can go further simplifying that result. T n by 3 to the power k, which I have written, that I am writing it simply. So n by n to the power 1 by 3 it is written. Okay, so if you open it, it's n to the power 1 by 3 and 3 to the power 1 by you can say, if I open it, 1 by 3, then 3 to the power k minus 1 by 3, if I open the 1 by 3. Okay, so let us think we opened it for a while, or you can say, better we can take this one, 3k minus 2 by 3. I have entered the 1 by 3, which is as a power that I entered it here to make it simplify. Okay, so n by 1 by 3 by 3 to the power 1 by 3 as per this formula. Next, n by 1 by 3, 3 to the power 0, because 0 into 1 by 3 is 0. Okay, next, t n by 3 to the power k plus n 1 by 3. Next, 1 by 3 to the power k 113 plus 1 by 3 to the power k minus 2 by 3 plus. It's not that much problematic, but sometimes what happened, we thought might be a problem which we cannot solve it. Okay, so we are thinking, but it's not difficult. We are finding the pattern, that is what we need it. Okay, you can check 3 to the power 0. Okay, now I'm ending with it. Next thing is, what we have to go for next. We think we have, as we are taking assumption, assume we have reached we have reached the base condition. Why we are going for it? Because we are finding the number of times we are running is k, but what is the value of k? To find the value of k, we assume that we have reached our base condition, what is written as t of 1 is 1, which is there in the example, or you can say the question. As for the question, the base condition is t of 1, means when n value is 1, the value is 1, the cost is 1. So from this, our function is this one. This function is n by 3 to the power k, equivalent to t of 1. Clear na? Next, the cost here will be equal. Without the function, the cost could not be equal directly. Next, n equal to 3 to the power k. To find the value of k, we are taking a log both the side with the base. Like which base? 3. If I take the value of 3, then I can say here 3 k, then only the k value we can easily find out, because log 3 base 3 will be 1. Okay, log, then I'm just changing the value now. K log 3 base 3 equal to log n base 3. Clear? So here you can say it's 1. K equal to log n base 3. Done. Now we are substituting, but before that, we though we said like we reached the base condition, next we should write t of n equal to, we say we reached the base condition, you can write it, or else you can put the value there. If you're putting the value on the k value will be log n base 3. As per the log you can say as per the log, it could be like suppose 3 log n base 3. So n could be here and 3 could be exchanged there. It's a property of log. N by n to the power log 3 base 3. So this is 1. N by 1 is 1. So from that also you can say t of 1, not an issue, because you reached the base condition now. Okay, when you reach the base condition, you are indirectly approaching the base condition. The constant is the answer here. Next is n to the power 1 by 3 we have to write. Next 1 by 3 to the power, because 1, the power of 1, above anything you can write will be 1, because power of 1, anything will be 1. Clear? 1 to the power 0 is 1, 1 to the power k minus 1 3 is 1. So that is why I'm just taking the value outside of it. Clear? Next 1 by 3 k minus 2 by 3. Clear? Like we are going for it, 3 1 by 3, here 1 by 3, then 1 by 3, which is a 0. This is 0, because 0 is there, so 0. Clear? We can switch here, we shouldn't write that one, better we can say it's 1 by 3. Clear? Now as per the formula we know, to find the sum of the GP series, we can have to check for it. You can go for the detailed video of it, where you'll get as for the GP series. The GP is here, the A is 1 and the increment and decrement is 1 by 3. So 1 by 3, the value of 1 by 3 is less than 1. So that's why what we are doing, 1 minus 1 by 3 by 1, A by 1 minus R. Okay, that is the answer. N to the power 1 by 3. Here it is 3 minus 1 by 3, or 1. Next n to the power 1 by 3. Next 3 will be the above. Next 3 minus 1. Okay. N to the power 1 by 3. 3 by 2. So some constant is getting multiplied. You can say n 1 by 3 into some constant, which is equivalent to n by 3. So the time complexity is big of n to the power 1 by 3. This is also correct. Or big of root cube. This is also correct. Not an issue. This is also correct. I'm writing or big of n to the power 1 by 3. Some constant is getting multiplied. You have to write C represents constant. Or big of root cube into C, where C is constant. I'm just writing where C is constant. Clear? If you're writing this way, it is clearly depict the answer how you are getting using iteration method. So I think it's clear enough. If you have any doubt, you can comment below. And for detailed lecture video, you can check from our channel. Thank you for watching this video. Have a good day.